Welcome to part 4 of the video build series on how to build a USB hotwire CNC foam cutter, and this is quite a long video, so I'll put some timestamps in the description so you can jump to the parts that you're interested in. So what we're going to cover in this video is the wiring, how we're going to wire the controller up to the stepper motors. I'm going to check the axis that they all work in the right direction, so when we tell it to go forward it goes forward. Then we're going to check the calibration. That's making sure when it gets a code to move, say 20 millimeters, it moves 20 millimeters. Then we're going to do some testing on setting the hot wire temperature. And then what we'll do then is we'll do some test cuts. And then the last part, which is the longest part of the video, we'll discuss some software that you can use to generate your own G code. So there'll be 2 free options and some paid options as well. So let's get started. So now you've got your hotwire CNC foam cutter machine built. So we've tested the electronics, we've got the mechanical side built. What we want to do is get the thing wired up now. So we know that the controller works okay because we've tested it in part 2. So as I said in part 2, the wires that come with the Arduino, I think they're only 1 meter long on this, and as I said, they'd be much too short. So what we need to do is lengthen the wires. So what I've done is I've just used some cable I had already for I've had it for years on a different projects, and this cable is actually it says on here that it's 24 gauge and it's 0.2 of a meter. So I've used this to wire the motors in. So you can get longer wires. I think I have seen 2 meters. Don't know whether I've seen 3 meters, but this machine doesn't normally sit here. I've just got it in here for the build videos. It's normally out in the shed, and these towers tend to be further apart, so you might even struggle with 2 meter cables. So that's why I've decided to wire them in separately. So I've used the cables that have come with the stepper motors, and I've just spliced them in, and I'll show you that in a bit more detail. So to actually mount the Arduino and the ramps board, I've used a piece of acrylic sheet. So this acrylic sheet I've had kicking around for quite a few years, and it was actually a piece of furniture that, and when we decided to chuck it on, I saw it and I thought, I'm sure that'll come in handy for something, and I have used it for quite a few things. This is about 9mm, but really could use anything. And all I've done underneath, you see I've done some testing on here, I've just glued some little bits of MDF on. So if we have a look underneath, you can see the MDF on there. And I've just chamfered them edges off, and it's just, you can see they've just been super glued on. That's some of the kicker that's caused that mark. And all I've done is, you can see from there underneath, I've just drilled through on the Arduino. So what we'll do is we'll take the top off and have a look. To mount the cooling fan, what I've actually done is use the original box that the ramps board came in. I can't remember if it was a ramps board came in this or the Arduino came in this, but it was in here. And I did look on Thingiverse to 3D print a proper enclosure, but the print time was something like about 7 or 8 hours, so I didn't want to spend 7 or 8 hours just waiting for a print. So I just got on and made this, and to be honest, I think this has worked out better for the way I'm doing it. So this isn't the only way you can do it, wire it up. You may decide to do it a different way, but this seems to work okay so far. I suppose time will tell. So we'll take the cooling fan off. And it does provide a bit of protection for the... And what we've got here is just on some standoffs on the top part. So if we have a look inside there, you can see these are the original wires that came with the stepper motors, and all I've done is use these strip blocks here, and these strip blocks are screwed down to the board, and then I've just cut into them and then on the other side of the, so all I've done at the other end there is put another small strip block and then carried on the stepper motor wires up to the stepper motors there. So I've done that on both sides. Because I've got the controller next to the X-axis, I've been able to use the original wire for the X, because it only goes from there to there. So I've used the original wire for that one, and all I've done is just taped them up. See, there's quite a lot of wires here, but that's the nature of the game. So I've wired up each motor, and I've used different electrical tape on here just to colour code some of it. So what I've done is, when I've done the wiring of these, I've then pulled the stepper cable out there and then go to the corresponding cable, and then use the multimeter and check continuity on each cable and make sure we've got good continuity there. So it's important you do that, because from video 2, if you've had it all connected up and you know it works, if you put it together now and something's not working, then the chances are it's one of these connections that are going through. And for the standoffs, all I've done is I've just tapped some holes in the acrylic with a 6mm tap. So these are the cross dowels that we've used elsewhere on the build. So because I've got quite a few of them, I've utilised them. So I've just tapped into the acrylic. As long as you don't tighten it too much, it's absolutely fine. And the Arduino and the ramps board are on some little standoffs there, and you can see it's not, I haven't really tightened it down too much because I don't want to put a lot of pressure on these boards, but it's enough to keep it in there. And then what we've also got in here, we've got the fan wired into the 12-volt supply. So these two wires here are for the hot wire, and this goes on to connection D8 on the ramps board. In the controller software, that's connected up to that, so we can adjust the current going through there. And on some initial testing I've done, it seems to work reasonably well. But in the past, I've always used this eye charger, and this has a foam cut option on here. So that's about it for the wiring of the Arduino Omega to the stepper motors. So far in testing, it seems to work absolutely fine. And you might decide you don't want to do it like this, but so long as you get the connections to the motors in some ways, it should work okay. And as I said previously, don't forget this fan. So these drivers in here are the DRV8255 drivers. They will handle up to, I think, a 2-amp burst, but they will get quite hot at that. But I think because this machine's not under any real load, I doubt whether they'll ever get to that. So, but do put the cooling fan on there, and then you won't be taking any chances then. So now we've got it all wired up and working, what we need to do is check that the axes are working in the correct direction. So when we, on the jogging buttons, press a plus, they go in the positive direction. So when I first got it together, I did have a problem with the y-axis going in the wrong direction, and it took me a little bit to figure it out, but we got there in the end. So we'll just go on to the controller, connect, and then we'll power on. So as soon as you power on, the motors are actually locked. And what you're doing anything with the actual machine, don't just leave it powered on them, because while these are locked, there's current going through them. So just power it off, and then you won't run the risk of burning out the. So what we need to do then, if we just go onto the jogging buttons, and what I suggest you do is on the jogging settings here, just set it a small amount, so 10mm, and then the best thing to do is to move it out into the middle. And so if it does go in the wrong direction, it's not going to jam into the end stops. But this one's actually working okay. So when I do an X plus, see we're going forward there. I do a Y plus, so we're going up there. And then if I do a Z plus or Z plus, So we're going up there on a Y plus, and we're going forward there. So that's all working absolutely fine at the moment. But if you do find one of them's wrong, what we have is go into the Arduino. Get the Arduino up. And I've documented all this in the ebook as well. So if you just want to download the ebook, all the instructions are there as well. And load up our firmware sketch, go into defaults. It's round about line 280. So you can see I've actually changed this. And what it's got there is, it's got a binary word there. Each bit represents one of the axes. So it tells you just to flip it. If you want to flip the axis, you either change it from a 1 to a 0. What I found is, unless I put the actual decimal equivalent value in of 65 there, I couldn't get it to work properly. So if you do find one of them's wrong, change the value above and then just put it into a calculator and get the decimal value of the binary word there, and then put that in, and then upload the firmware again, and you should find they're working in the correct. Right, so now we've checked all the axis directions and they're all working correctly. What we can do now is move on to the calibration, and what we want to do is make sure that when the G code goes into the controller and tells it to move a certain distance, it actually moves that distance. Now, if you've downloaded the firmware from a website and you've built your machine with exactly the same parts as I have and use the same microstepping, so if you use these 10mm by 1.5 threaded rods and you've set it to 8th microstepping, then the firmware loaded into the controller, it should just work. So what I found is it's been spot on. Now if you've decided to use anything different, then we'll have to recalibrate. But we also need to check to make sure it does actually move the distance that we've told it to move. So the way to do that is to make some sort of pointer. And we're only going to check the x-axis because of all the other axes are the same. Once we've got this set, it'll be the same for the others. So I've made this pointer up with just a paper clip and screwed it down underneath one of the bolts for the draw slides. And I use this for all here because it's nice and bright and yellow. It's a lot easier to see. So what we'll do is we'll just move this underneath and I'll clamp it down so it doesn't move. And then what we're going to do is line the pointer up with a mark on the machine here. So that looks, let me just get right over it. Yeah, that looks as near as, damn it, right on 250 distance, and check that it actually moves that distance. So I've got it lined up on 250 there. I'm going to tell it to move 100mm and it should come to the 150 there. So, and the way to do that is there is 100 on the jogging interface. You can move it that distance, but what I've found is that when you click that with a mouse, you sometimes give it a double click and it moves more than you think. So the way to do that is to use the G-code command. So we've got a manual input command there. So what we do is we type in G01. So we're going to move the x-axis 100mm and use a feed rate of 350, which is the default feed rate for this anyway. So what we should find happens is that it moves up to the 250. So let's send that command and see what happens. With any luck, it should end up on 250. Right, let's have a look at that. That more or less looks spot on. So I have checked this before, and the settings I've put in the firmware work perfectly for this. So as I said, if you've downloaded this firmware and used all these same parts, you should find you shouldn't need to do anything. And as a good test, what we can do now is if we home it, so we can actually use the home XY on the jog of the left carriage, it should go back to where we started from, and that will check if there's any backlash in the machine. Always amazes me when these things move from a computer. And let's have a look there. Yeah, we're absolutely dead on there. So the calibration is perfect. Now, if you do find it's different, so if you've used different threaded rods and different steps, then you'll have to put a different setting in and do this test. Now I'll link you to a website where you can get the settings for this. It's actually a site for people building 3D printers, and it's got all different settings there for different pitch threads and pulleys, and so I'll put a link to there. So if you're using something different, but if you find when you do this on yours, it's only a tiny bit out, then it might be the steps per millimetre needs to be adjusted. So if we found that we only moved 90 millimetres there, so if we moved from 250 and we only went to 260, then there's obviously something not quite right. So what I'll do is I'll put a slide up here showing you the calculation we need to do, and then once we've done that calculation, we'll get a new figure for our steps per millimetre. So on the software there, if we go into settings, and you have a look at the top part there, we've got our settings there. So for this setup, it's using 1066. So what we would do is the new figure that we've got, say we got 1200 for some. So all we would do was we would put 1200 in there. And then if we just come out, so accept it. So now, what we'd find now, if we move it now, it won't end up on the 50. So go back to the interface. If I give the same command now, we'll find it goes. So what's it going to do? Is it going to go less or more? I'm not sure. We'll find out. What do we think, more or less? It's done the same. The reason it's done that is because the way this controller software works, it doesn't actually take the settings in here. Is we have to go back into the Arduino software. So we'll get Arduino back up. And we have to actually go into the parameters and change the settings. Tab. And it's right down near the bottom, I think, around about line 260 something. So there's our steps per millimetre there. So what we would do is we would then change the value there to the new value we've calculated, start up the Arduino again, and then check it again. So it's a little bit long-winded, but as I said, if you built it as I built it, it should work with these settings. That's how we check calibration. The other thing you can do as well, if you want to even be more accurate on the calibration, is use a greater distance. So if you've got a longer rule and you want to start right near the back and say come up 500 millimetre and check it then then you know, the greater distance you do, the more accurate it's probably going to be. So that's something else you might like to try as well. So that's the calibration done. So the next step is to get the hot wire working, and we want to do a little bit of testing first, because this part can take a little bit of time to get right. You know, testing with different temperatures and feeds, and what you'll need is a lot of bits of scrap foam to test with. So I keep all little bits of foam that I come across in packaging, and it's really useful for testing. So we're going to use the Arduino, and the software that we're using, the controller software, has an option to use the D8 connector on the ramps board, and that would normally power a heated bed or an extruder. Not sure which way around it is, one or the other, on a 3D printer. So what we can do is use that, and I've got that wired in at the moment, going to these two little crocodile clips there. What we'll do is we'll connect up, and then on the controller software in the hot wire control panel there, we can adjust it until we get a good voltage and amperage to melt the foam. Now, as regarding the wire, I've tried various types of wire throughout all my foam cutting, and the best wire I've found now is to use very thin wire, and this is 0.5 of a millimetre, and it was actually given to me some time ago by a friend of mine, his father, who was an electronics engineer, and this actual wire is called Litz wire. That's L-I-T-Z, and I think it's very similar to nichrome wire, and I've got a roll of it, probably outlasts me, the roll, and it works really well. So because it's being so thin, you don't have to put as much current in it to warm it, and it means when you're foam cutting, one of the things you have to take into account is what's called the kerf value, and that's the amount of foam that is melted by the wire. So most foam cutting programs will have a compensation in for that. So if you're using a really thick wire and you're having to put loads of current in there, you're going to get a very big value, and you have to account for that in your build. But by using very thin wire and getting the current just right on it, the amount that it melts away is very minimal, as you'll see when we do some cuts. So, but getting this right can take a little bit of time. So what we'll do is we'll switch the wire on. So we'll switch the controller on first. Right, we'll just zero everything out. Right, as soon as we connect, you'll find that your steppers are energized, so you shouldn't be able to move any of the thread rods. If you find you can move one, it means it's not connected properly. Right, so on the panel here, I found with some testing, if I put it up to about 4.2 volts, I think, there's 4, and all I do then is just do a little bit of see, that's melting through really well there. You don't need much tension on here, because as the wire's going through, it should be cutting by what's called radiance. What we'll do is we'll put some test pieces on, and I've got a Clark Y aerofoil set up. So what we first need to do is just jog the wire down a bit, because it's up too high at the moment there. So we'll just go down 10 on the Y. Right, so that's looking pretty close there. So what we'll do now is just zero out the axis now. And then what I'm going to do now is load in a Clark Y test piece. And then I use double-sided tape again. So here's a couple of, this is to be the same thickness as our piece of foam that we're going to use if we were cutting the real wing. So all we'll do is we'll just, that looks a better edge there, we'll just put it as quite close to the wire without touching. Right, so now for a second test now. And I've just adjusted the wire temperature down a little bit. So if we set the, so it's showing 3.6 volts now. And when I've done a little bit of testing, that still goes through. So that goes through okay still. So what we'll do, we'll load up the, we're all zeroed out. So we'll load the file up and try again. So as I said, this is a bit trial and error to start with, and you want to try it out bits of scrap foam first before you commit any, you know, good blocks of foam. I know that from experience because I've wasted a few big blocks of foam. When I first started doing this, I had an 8x4, 8 foot by 4 foot sheet of foam I bought, and I never actually made anything out of it. I ended up using nearly all of it for testing, and because I was learning and not really understanding too much what I was doing back then. But gradually I got it, and yeah, if you can see where the wire's going now, there's not such a big gap there. So now we're doing the little square spar section again. Yeah, that looks a bit better as well. Right, so now we're going back to, and we'll start doing the aerofoil now. Not the quietest of machines. It is a good idea to wear one of these when you're doing this, although I ain't got mine on. But the fumes from some of this stuff is not particularly good, especially the pink foam. So this type of foam here, the fumes are not particularly good off of that. And I have stopped using this foam because what I'm finding now when I'm sanding it, the dust that comes off it does affect me a little bit. I tend to be sneezing for a few days. So all my builds now I'll be doing with the white foam. So there we are, run number 2. Right, we'll turn the wire off. Wire's off. And then we'll just power off the motors. Let's have a look. Yeah, so that's looking, so let's get the last one we did, which was, yeah, it was that one. So if we look at the 2, you can see the difference, especially around the spar hole. So if we just line them up, and we might even get away with dropping the temperature a little bit more. So if you can see on the, see it even more noticeable where the wire's gone in. So if you see, the gap's a lot bigger on the previous one we did. So that's looking like quite a nice little airfoil. So guys, if you have a look at this here from an overhead shot, what you'll see here is when either the speed or the temperature is incorrect. And if you sort of watch it, you'll see that the actual wire is being dragged on the foam. So one of the tests I normally do is when I'm cutting, I look right overhead on the wire and make sure the wire is straight. And if it's bent like this, it means that there's something not quite right somewhere. So we've either got the temperature's not high enough or we've got the speed too fast. So you won't get a very good cut doing this. And you see it's putting extra tension on the spring as well. So this is what we don't want. So now we've got everything working and we've used the sample G code. The next thing you're probably thinking is, how do I generate some G code for my own design? Well, we've got a few options. There's a couple of free ones and some paid ones, and they've all got their pros and cons. So what we'll do is start off by having a look at the first one, which is probably the simplest one to use. And if you've never done any of this before, what I suggest you do is try this one. So the first one we're going to look at is called Wing Cutter Wings in G Code, and this is by a guy called David de Swarfer. He's quite well known on the Open Builds forums for he does a lot with SketchUcam, which is a CNC program that I've used in the past, and that's a good one as well. So here's the website, and I'll put links into the description so you can find these, and they're all on my website as well. So if you go to my website and have a look in CNC, and if you go to probably the best one is to go to the software. Yeah, probably the best one there is free CNC software for 3 and 4 axis machines, and that will give you the links. So this is David's website. It is looking a little bit dated, but it still works. And you know, as the old saying goes, if it ain't broke, don't fix it. And what you'll need to do is you'll need to log in. And the reason for that is you can upload your own wing profile. So if I can remember to log in, I'll log in here. What do I log in as? Try this. Yeah, looks like we're in. Right. And this is fairly simple, and it's a good one to start with. So first of all, we can give our model a name. We'll call it, let's just do flying wing. Wingspan. So as you can see there, if it's the whole wing, put the whole wing length in. But if it's a tapered wing, so we'll do a tapered. So let's go for 480. Root length. I'm just making these up at the moment just to give you an idea. So we'll go for let's try 270 there. Tip length 145. Trailing edge limit. Now, this is quite a good one here. It prevents the foam from going really thin. So what you'll probably find is, as you're getting down towards the trailing edge, it can get very thin, but there's a limit here. So, so I think this is in, yeah, so profiles in millimeters. So I find quite a good one is 3mm. Sweep back. So this is going to be quite a swept back wing. So let's do 250 there. Gantry length is mine. I usually have at 1,000, and here we can put the profiles in. So if you look on David's site, he's got quite a few in here, but you can upload your own. So we'll just try this one. And it gives you all the coordinates there. I got it right the first time. Right, we'll just copy that to the tip profile. The foam core, in fact, this is how big your foam block is. So our maximum length is 270, so 300 will probably be 5 there. Foam thickness, I tend to use 50mm foam for most things, and I found that the feed rate works reasonably well on this, but we can always adjust that. And then we've got the, so you can, yeah, I thought you could use either inches or millimeters in this. So we'll press update, and probably what you'll find is we'll get an error. And the reason for that is what the software is trying to do is do both wings in one piece of foam. And as you can see there, the foam is not thick enough to cut both panels, but that isn't a problem. And so here we can see the flying. So what's going to happen? Or you can, if you want, download them all. So we'll do that, yeah. So we'll download them into, and we've actually got the PHP code here. So if you're a bit of a programmer and you know PHP, Windows is just going a bit crazy at the moment using OBS Studio. It's a bit of an old laptop now, so it does struggle a little bit. So what we can do now is we'll just extract the files. And these files NC are the actual G code. Now the problem is what you'll find is when we first, if you try to load this into the controller, I think what we'll do is we'll plug the controller in, and right, so I'll bring up the controller software. Compile and connect. Right, so if we try and load one of them files in, now it loads in fine, but I think what we'll find when we run it, if we have a look here, we've got some different axis letters. So let's just see what happens when we run it. Yeah, so what we get here, so it's got so far, then it's gone to error. And it doesn't like some of these codes in here. What we need to do is open this up with the text editor. Now the one I've got installed on my Windows machine here is Notepad++, which is a free program, and it's really good. I use it all the time. So just open that up. So what we do is we need to replace this letter V with the letter Z, or Z if you're in the States. So we'll go to replace, and we want, it picks up whatever's highlighted, so we just want V, and then we want Z. So if we now do a replace all, So 65 lines replaced. And then all we do now, if we do a file, save. Now I think there's an issue here, I think, as well. It doesn't like one of these lines, so we'll investigate what that line is. So if we close that now, we'll load up the foam cutter again, open. So what we'll do is we'll run that now. You see it's running now. It did up till there. So it's not liking this line for some reason. So what we'll do, I'll just pause this and we'll go and have a look and see what the problem is with that line. So the other thing we need to change on this code is the software we're using, which is basically the gerbil implementation with 4-axis. It doesn't like these extra settings here on this line 13. So G90 is okay. That's absolute programming. If you ever get some of these codes and you're not sure what they are, if you just do a search on the internet, you can find out what they are. And there's a good site, well, on Wikipedia, just do G codes and you can see what these different codes mean. So this G49 tool length offset. So I think it was originally designed this for using with Linux CNC, and you could actually run this directly from within Linux CNC as well. So I think this is to do with the kerf compensation, but we haven't got that with the with our gerbil 4-axis. So what we need to do, on the G64, let's just go back and have a look at the G64 default cutting mode. I'm not exactly sure what that means, but when I've tried it doesn't like it. So, so all we need to do is take them out. Save the file, and if we go back to our, and if we reload it, so if you press stop and if you do a reload there, it will reload the latest code. Go back to the top there, and see now we've just got a G90 now. So we're still connected. So we should find now it runs. So let's have a look. And there we go. So it does take a little while for the display to sort itself out. It's just traversing to do the first cuts, I think. So once it gets there, we might see something that looks a bit more. Yeah, and as you can see, because we've got a swept back wing, the UZ view is a lot different from the XY view. So here it is finished. Now as you can see, the actual displays look a bit strange, you think, but what you're actually looking at, you're not actually looking at the wing profile itself, you're looking at the path the wire's taking at the end of each gantry. So on the XY view, we've got this shape here, and then we've got this shape here. So if we were just doing a straight wing, they'd both look pretty much identical. So as you see, when we did the Clark wire test, we just got a normal shape out. But swept wings can be a little bit more challenging, but that's where some of the paid software has some slight advantages. I haven't actually got the foam cutter connected, I've just got the controller connected, because doing this in my little office, and I don't think the wife would be too pleased if I had the foam cutter in here. It'd be a bit of a struggle to get it in anyway. So the cutter's connected, and it's just potentially sending the codes to the stepper motors. So that's the first free one, and what I suggest you do is start off with straight wings first of all, and just get some practice with them. And but it does work reasonably well. You just got them few little settings to alter, and then what you would need to do then is set your temperature as well. So from the previous part of the video, just do a little bit of testing to find your ideal temperature, and then your speed. If you find the speed is a little bit out, so you want to increase it or slow it down, what you can do in the actual G code, that setting there, F60, so that's the feed. So if you wanted to slow it down or speed it up, you could alter that setting there. So probably what I suggest you do is just put a bit of scrap foam in first of all and test it with this, and get your settings right for the type of foam you're using, and get your speeds right as well. And as I said, it does take a little bit to get them sorted, but once you've got them sorted and you've had a bit of practice, it works reasonably well. So that's the first one. And then the second one, which is another free one, is Jellycut. So I've got the Jellycut page open here. So what I'm going to actually do is reinstall Jellycut on this machine. I've actually removed it. And there are a few little things we need to do to Jellycut. I've actually got a blog post on what we need to do with Jellycut. Yeah, there we go. So we've got there how to use Jellycut G-code with the Gerbil 4-axis CNC foam cutter. So all the details are in there, but we'll just go through it. So all the details are there, but I'll show you what you need to do. So what we need to do is download Jellycut. And as you'll see, Jellycut is made by a guy called Jerome. And it's quite a good program. It does take a little bit of getting used to, but some guys have a lot of success with it. So we go to download and just download the latest version, 2.4. So this is in August 2019. So, if you're watching this a lot later, it's a later version, then you obviously download the later version. I've already got it downloaded anyway, so I'll not download it again. So we'll go into all my downloads. I should have Jellycut in here somewhere. There we go, Java. Jellycut, there we are. So there's the Jellycut setup. So Windows is just wanting me to confirm. It's all going to the wrong screen here. I just accept all the defaults. Now create a desktop and a quick launch. And it's not a massive program. Now, if you'd like to, please do support Jerome. He's put a lot of work into this. And what we can do, then we launch Jellycut. So once we accept the defaults, we come up with this screen on Jellycut. So all we need to do, select our language. The problem with Jellycut, it won't work straight out the box with there for a similar reason to the Wing Cutter in G-code program by David. So what we need to do is we need to go to options. And the first thing we need to do, we need to change our axis letters. And I only use Jellycut for generating G-code. You can use it to actually power a foam cutter. So you can see there's various options here for the parallel port configuration, but I only use it for the G-code options. So we need to change the axis letters. I think it's picked up my previous settings here. Once you first install Jellycut, it has a lot more options there. So let me just bring up the website. Yeah, so when you first bring up Jellycut, as you can see there, it has a lot more settings here. I think because I've installed it before, it's brought up my default settings. So basically what we need to do with Jellycut is two things. We when you install yours, you'll probably find the access letters will be different. But I've already changed, so we need to make sure on the X2 we've got U and Z. So the only one we need in is a static header G94. The other settings in there will cause problems with the controller. So that, I think that's basically all we need to do there. Communication mode, yeah. And that's how we tell it we're using G code. Now you might find you've got different options there, but basically all we need to do is set the G code. There is some serial ones there, but I think it requires some specialised hardware to get that working. But as I said, all I really use Jedicut for is to generate the G code, and that seems to work fairly well. So here we don't need to. You see, there are still some French translations in there. You can go in and actually alter some of the language settings. I have done one or two of them, so it makes a bit more sense. So with that, we should be fine with Jedicut. So I think I have got a wing up, so let's, yeah, there we go. I've got a, let's try. Yeah, so I'll open this 42 up. So this is basically what we get with Jedicut. So this is what I've done previously, but so once we've got the settings for Jedicut, what we can do then, we can then go through Jedicut and create a new project. What I'll do, rather than go through everything here, I'll link it to, because I have done another video on using Jedicut rather than rush through it here. So we'll just find that through, and I'll put a link into the description. I think if you do a search on YouTube, it's one of the first that comes up. There we are, it's that video there. So if you just put a search in for Jedicut, I'll go through how you set Jedicut up. And the first part of it is about making a tapered wing, and then the second part goes into actually using Jedicut. So rather than go into lots of details in this video, I'll link you to that one. So that's quite a longish video. That was using my old machine, but as long as you put the settings in for this machine, it should work just the same. What we'll do, I'll just load that file back in. And all we need to do then, we go to cut. And what Jedicut does then, it generates a G code. So if we now go and have a look and you think, what's happened now? It's actually wherever we told it to put the G code from the tools options settings. That's where the G code will be. So we're going to have a look at that. And that's the G code generated by Jedicut. So what we'll do is we'll just try and load that in. Still got the controller running. And we'll open the file. One of the things about Jedicut, it works in what's called incremental mode. So it doesn't work from the 0, origin. It works from where the last point was. So when you see the G codes, they're always very small figures. So if you look at the G codes there, they're only very small. And it does seem to cause a bit of a strange display. Right. But hopefully, I've checked this out before. So hopefully now it should work. We've got a slightly faster feed rate on this. We've got F100 on this. So let's see what happens. There we go. So we can see we're just starting off here now. I think this bit here is all to do with it working in incremental mode, and you can see there on the state it's switched into incremental. So we'll leave that running a bit like we did the last one and come back to it and see what it looks like. So here we are, here's the finished results with Jellycut. As you can see, we get this bit of a weird display, but I think it's to do with the incremental settings that it uses. And these are the wire paths, actually, not the actual profile shape. So this is the path the wire's taken right at the end of each gantry. Yeah, so that's Jellycut. Does take a little bit of getting used to, but if you watch my video that I've mentioned earlier, it will give you more insight on how it works. Right, so the other options we've got are some paid options. The one I've used for quite some time, and it isn't available anymore, but I'll just show it to you because it's the one that I've made nearly all my models with. Profili Pro 2. Now what will happen, it says I'm registered there because I have a USB dongle. Just show you that on the webcam there. So this is my little USB dongle from Profili. So when I plug that in, it will show me as registered. And that has all the license keys, and this is what you get when you haven't got a license for it. So you can just do continue. Everything works, but you can't save the G code. So I just, it's under panels. Right, so this is my Hurricane outer wing on Profili. And basically all you do is you put all your dimensions in and you go through it, tell it what airfoils you want. And there's various other settings. You can put in lots, spar settings, lightning holes. So that's basically Profili Pro 2. So I won't go into that anymore because you can't get this anymore. So we'll come out of it and we'll look at the new version. So the new version is called DevWing Foam. See, I've got DevFuzz Foam 2 there and DevWing Foam. So I'm going to DevWing Foam. So this is the main screen. And there's an example one in there. So this software comes from a guy in Italy that runs a company called DevCAD, called Stefano. And I've used this software for quite a few years. And it's not the most modern looking software, but it works really well. So the example I've got there is actually for a Spitfire wing. So if we just step through this, and this is a lot more advanced, you can actually bring an image in and trace the outline of the image and then set the panels up that you want. So you've got a wingtip there, a wingtip, and then you've got two panels there. And although it's showing them curved, you wouldn't actually be able to do them as curved because they'd come up straight, so you'd probably have to do a little bit of sanding on them afterwards. And then you go into as you can see from this, there's a lot more settings in it. I will be doing a video on DevWing Foam, probably in the next video after this series to go into it. But it is a lot more comprehensive than the other programs, and there's still a few settings in there that got me a little bit puzzled as well. And then we can go into, there's a lot more options. So we can say where we want to split the panels. So you could actually do these as little tiny panels and join them together a bit like DevFuzz Foam. And then we can define the airfoil. So the root airfoil is defined as this Jawowski. And then the tip airfoil is interpolated. So basically what it's doing, it's just working out the profile from the size of the wing and and the panels. So I haven't tried that one yet. So generally what I do is put the other airfoil in there. Oh, and one of the other things that's really good with the new version as well, you can define dihedral, so you can set the dihedral, and you can also set washout as well. And this is optional sheeting if you want to sheet the wing afterwards. I've never used that on any of them. And we've got leading edges on here as well, so you can set up your leading edges. And then we can do trailing edges as well. And then we can define spar jigs and other. So it's got a wizard there with different settings in there. And then also we can add flaps as well. Sorry, ailerons. I think you probably do flaps as well. So it's got all the different options for that there. So it is a lot more comprehensive than the old Fully Pro. But having said that, it does take a lot more learning. So then we can put lightning holes in as well. And you can also look at the side view as well. So we've got lightning holes there on different sections. And there's various options to do with that as well. And this is optional wooden ribs. One of the things you can do with Fully Pro, one of the things you can do with Dev Wing Foam is you can actually create ribs with a CNC machine. It has an option to do that. I'll show that in a minute. This is the wingtip if you want to do the wingtip. Let's have a 3D preview of that. What does that look like? I'll bring that onto the... This is a 3D preview of the wing. So you could actually do a mixture with this. You could actually cut some ribs out if you've got a CNC machine and then have the foam sections as well. And the last page of the widgets is this set G-code strategy. And normally you don't want to mess with this. And this is this one here, G93, is what's been added to Dev Wing Foam. Fully Pro doesn't have that, which I found out when I was doing my T45 Goshawk, but I'll discuss that in a later video. So that's all the design stage done. And then what you do then you have a look here, you can cut parts by a 3-axis CNC milling machine. So you could cut them parts out if you wanted to. But then what we're doing here is we create a foam project using the selected project. So I think I've actually done one for this wing here. So we'll load that one up. There we go, open. Gone onto the wrong screen again. There we go. So it starts off by the block selection. So you say whether you want to do a right or a left block. So I've just put a right in here. And then within the design for this, I've actually done some ailerons on it as well. I thought that's something I'd try on this new version. If we have a 3D preview. So you can see the, if we go back to the beginning and then, so we'll get a simulation there of how it's going to cut. Yeah. I'm not doing any more on that. So we can control the cutting order. So this is something else I've got to spend a bit more time on as well. And this is the placement of the foam block. And this is something you probably, if you look at the Jetty Cut video, this is something I explained in the Jetty Cut video of how to rotate the wing section, so it's parallel with the trailing edge, and that way you're not wasting a lot of foam, and not sometimes if you just do it so the tip and the root are parallel, it can end up taking a lot of travel on the machine, especially if you've got a very large foot back wing. So I always do this because one of the main reasons it does save foam, and quite often I can get a full wing out of one piece of foam. The only downside of that is once it's come out, you then have to cut these at the correct angle, but that's not too difficult. This is actually for cutting the block that you're going to use to the correct height. It'll probably come up with an error here, yeah, but it doesn't matter that, you'll just say no to that. And now what we do is then we would then tell it to create the G code. So probably this one here, create the 4-axis G code for both carriages. Now what's going to happen here, as soon as I press this, it's going to give me an error because we haven't got a license. But when I plug the dongle in, it won't do that. So what I'll do is I'll just close this down. I'll put the dongle in. Right. So if we go to the cutting project now, if we just go through to the end. Right, so I'm going to create the G code now. It comes up now. Now this is where you would change the axis. So you've got the ability here to change the axis letters, and there's quite a few listed in here. So all the common ones for foam cutting. So you can change the axis here. And we also have got a command here to switch the hot wire on and off. I haven't actually tried that yet. And we could use relative coordinates if we want, like Jetty cut. But right, so what we'll do, we'll generate this G code. So we'll just name this as V2. Save that, finish, and we can come out of dev wing foam now. Connect. Hot wire, G code. There we are. Open. You can see the wire paths there are quite so this particular wing has got washout in it, so this is the path of the wire, which it looks more exaggerated than what it actually is really. So we'll just let that run a bit. You can just see that this is going to take a long time to run, so I think what we'll pause it now, but you can see more with this. So Dev Wing Foam is a more polished program, and the one thing I haven't said is how much it's cost. They retail around about 80. Well, let's have a look. Let's go to Dev. Dev Wing. Got to be careful. There we are. Dev Wing Foam one. So there we are, €95. So what's that in? And when you look at the prices of some models, I mean even a reasonably sized model, let's pick something. So if you look at this Corsair, which is a nice size model, about 50-inch, you've $205 there, and then by the time you've got batteries and other bits and pieces, you know, so you're getting close to probably $250, $300, depending on how many batteries and that you need for it. So yes, DevWing foam does cost a bit of money. But if you enjoy making the models, and then especially when you start looking at some of these bigger ones, if you want to start making some bigger models, you start to looking into the $400 or $500 range, and that's when the machine starts to pay for itself. So that's DevWing foam. So that's just different pieces of software you can use to generate a G-code. Now, if you're just starting off, I wouldn't necessarily suggest you start off with DevWing foam, because it's a brilliant program, but it does take a little bit to learn, and there's even parts of it I don't fully understand yet. So probably what I would suggest is you start off with either the free one from, if we start off with the one here from David de Swarfer, and you can get your airfoils from various places. So you list it here where you can get your airfoils from. So I'll probably start off with something like that. Then as you get a little bit more advanced, probably use Jellycut. And then what you'll probably find with these programs is when you start to want to do different things, that's when you find the limitations. And so, yeah, free is always good. But the software from Stefano is really good. And I've used it for, well, ever since my foam cutting. So I think that just about is on the software you can use for G. So that's the final part in the actual build. And if you've been following along and you've downloaded the plans and the free ebook, thank you very much for purchasing the plans. If you have, I've been quite overwhelmed by the number that you have. And if you have built a machine, do send me some pictures and some videos. I'll create a page on the website with builds on and what you're building. I always love to hear from fellow enthusiasts what they're doing. So the next video is going to be some more software, because I think, as you'll find, building the actual machine isn't the difficult part. The part that does take some learning is the software. So the next video I'm going to be covering DevWing foam, which is quite a complex piece of software, but I'm probably going to do 2 or 3 videos on it and start off fairly easy, and then we'll progress and get more into it, and we'll actually build some full models, not just sample cuts, which you've been doing in these videos here. So we'll use the new machine to do that, and then we'll see how it comes out. So thanks very much for watching, guys. Nearly at 1,000 subscribers. I'm quite overwhelmed by that as well. So catch you later.